You will learn how to calculate the percent of change. Consider this. Suppose a school was getting 50 more students next year. Is this a big change or a small change? And would it be more helpful to know this information as a percent? Why or why not? 50 more students would depend on how many students there are in the school to begin with, whether it's big or small change. If it's a small school with only a few hundred students, then 50 more students would be a big change. If it's a very large school with thousands of students, 50 would not be that large of an addition. So knowing this as a percent of the number of students in the school, that would be much more helpful to know by how much the total population is going to increase. The percent gives you a better understanding of the change in comparison to the original amount of students. When you're calculating the percent that something is changing, again, you are comparing to the change in the two values. So what it is now to what it was before. This could be an increase from the original amount, or it could be a decrease from the original amount, depending on what you are trying to solve and what values you're working with. Regardless, the original value always represents the whole or the 100% in our percent problems. And the change is the part. What does it mean to find the change between two quantities? In math, when we calculate the change between two things, we are finding the difference between them, meaning we subtract the values. When we find the percent change, we need to first find the change between the two values that we are working with. So we will start by subtracting the two values we are given, and then we will second calculate the percent, what percent that change is that we calculated in the first step as compared to the original. And the original is always our whole. So I've changed the percent proportion and the percent equation slightly to fit the percent change scenario. So instead of our original part over whole equals percent over 100, and our original triangle, which had part on top, percent and whole, I changed the part to be the change. So C, and that is change, and the original is the whole. And this should be the percent. So change is our part, original is our whole. Let's take a look at some examples. In 2000, it cost $7.25 for a movie ticket. Today, it costs $12.50. Find the percent of change in the movie ticket. First thing we want to do is find how much in dollars did the movie ticket increase. So that is taking $12.50 minus $7.25, which is an increase of $5.25. When we find the change, we are always going to subtract the larger number minus the smaller number, whether the price is going up or going down. So this is our change, $5.25 has the increase, but now we want to know this information as a percent of the original. In this case, the original price we're comparing this to is $7.25. So we want to know by what percent did this actually increase. So when we do our proportion, if that's the method you're choosing, you're going to put the change, which is $5.25, over the original amount, which in this case is $7.25, and then x over 100. If you like the equation or the triangle method, the change is our part, $5.25 over $7.25, and that will give us our percent. When you solve this problem, regardless of which way you solve it, you're going to get an approximate increase of 72.4% increase in price. This should make sense because if we're comparing $5.25 of an increase out of what started out as $7.25, that would be almost a 100% increase since the original price it was $7.25. So about 72.4% increase should make sense in this case. Let's try another example. Last year, there were 750 students enrolled in Hampton Middle School. This year, there are only 685 students. What is the percent change in enrollment? In this case, we are actually decreasing our enrollment from 750 down to 685. This is a drop in 65 students, but I want to know what percent that is out of the original enrollment. So when we set up our problem, it's 65, and in this case, it's out of 750 because that's what it was last year. So when we say original, this is like chronological order. 750 is what it used to be. Now it's less than that by 65 students. So 65 out of 750 is approximately 8.7% decrease in student enrollment. Here are a few examples to try. Don't forget to first find the difference between the values given, and then take that difference or that change and put it over the original. Original is whichever one happens first chronologically. To answer this question, we want to compare the original price in 1960 to the price of milk in 2015. If we find the difference between these amounts, you'll notice that you get a $2.80 increase in price of milk from 1960 to 2015. This is greater than 100% because the change in price is greater than what the price was in 1960. So $2.80 out of 49 cents is going to be greater than 100 because our original value here of 49 cents is going to represent our 100%, and that's what we're comparing 280 to. Another option is, instead of subtracting first, is to compare the new price over the original and figure out what that is as a percent. So whether you do this as a proportion or the triangle, either way, the new price goes on top, which in this case is $12.50, and the original price, $7.25, goes on the bottom. Now when you solve this, you end up getting a 172.4% as your answer. But this is not the increase or the percent of change. This is what percent the new price is compared to the original. If we remember that the new price is 172%, 0.4%, but the original one was only 100%, we're still trying to calculate by what percent these values changed. So to do that, we can take 172.4% and find the difference between that and the original, which is 100%. That gives us our original or same answer that we came up with earlier of 72.4%. Some people prefer this method because the second step of subtracting 100 can be done in your head, and some people may think that this is a little bit shorter of a method than the original one I showed. If we do the second example that way, in this case, since 750 is our original enrollment, that's going to go on the bottom, and 685 is our new enrollment, so that's going to go on the top. Whether we do the proportion or the triangle, same idea in both. The difference is just that in this one you don't have to multiply by 100 to make it a percent, whereas in this triangle method you have to multiply your answer by 100%. When you do it this way, you end up getting about 91.3%. And remember, that is not our answer. That tells us what percent our new enrollment is, and our original enrollment is 100%. So we still want to find the change between those two things. Now in this case, instead of doing 91.3 minus 100, that will give us a negative amount, which although since we are having a decrease here, that can make sense, we tend to write our answer in these percents as a positive. So for this problem, instead of doing 91.3 minus 100, we're going to just put the bigger number, which in this case is 100 first, minus 91.3, which leaves us with that 8.7% answer that we came up with at the beginning. So that's a second option. If you like that method better, you may use that method.